Hey everybody, this is the 2017 free response question number 4. So this problem should look familiar to you guys. This is the one with the potato and we're looking at the internal temperature. So it starts out with an internal temperature of 91 degrees Celsius at time t equals 0. It says that the internal temperature of the potato is greater than 27 for all time t greater than 0, which is going to be important for one of the parts. Um, we've got this differential equation right here and our initial condition of 0, 91. So in part A, we're asked to write the equation of a line tangent to h at t equals 0 and use that to estimate the internal temperature at time t equals 3. So we know we need a point, which is that initial condition of 0, 91. And then we're going to need our slope, which we know is the derivative at that point. So it's dh dt evaluated at h equals 91. So it's going to be negative 1/4, 91 minus 27. And so we get then that our slope is going to be, let's see, negative 1/4 times 64, so negative 16. So our tangent line is going to be y minus 91 equals negative 16x. And then we're going to use that to make an approximation. So I always go ahead and just make it L of x then and move the 91 over. So if we're going to make an approximation here for the internal temperature at t equals 3, then we're trying to estimate h of 3. So h of 3 is approximately equal to L of 3, which is going to be 91 minus 16 times 3. So 91 minus 48, we get that h of 3 is approximately 43 degrees. And then we're in Celsius. All right, for part A here, this was worth 3 points in total. So it was 1 point for your slope, so getting that negative 16. It's 1 point for your tangent line, and then 1 point for your approximation. Part B asks us to use the second derivative and determine whether this 43 that we got was an over or under estimate. So that means we need to actually find the second derivative. So I'm going to start by writing out what our original derivative was. And we're going to use that to find the second derivative. So the second derivative then is going to be negative 1/4, because that just chills in front. And then we're going to need some implicit differentiation, so dh dt. And so we're going to plug in our dh dt again. And we end up getting our second derivative is equal to a positive 1/16 times h minus 27. And just as a quick reminder, just in case, this dh dt is this original derivative that we got here, and so that's where this piece came from. All right, so now we need to look back up at the top, and that piece that I highlighted, that this is where that kind of comes into play. We're told that the internal temperature, which is H, is greater than 27 for all times T greater than 0. And so if H is greater than 27, then we know that this second derivative is going to be positive this whole time. So since H is greater than 27 for all time T greater than 0, the second derivative, which is 1/16 h minus 27, is greater than 0 for t greater than 0. So h is concave up at t equals 3. So, and I forgot to talk about that. Sorry, I kind of got ahead of myself. In order to determine whether it's an over or underestimate from the second derivative, we look at concavity, right? So the second derivative is positive, which tells us the function is concave up. And if we have a function that's concave up and we draw a tangent line, we get an underestimate. So let's see. So h is concave up at t equals 3. Therefore, we found an underestimate. All right. I don't like the wording of that. I'm going to erase that. That was a bad way of saying it, but I was trying not to have to write too much. So therefore, our estimate is an underestimate. There we go. That sounds better. This one was just worth 1 point, so you have to include all of that stuff in there and then tell us that it was an underestimate in order to get the points. All right, part C here, we're given this other differential equation and we're asked to find the particular solution with this given condition. And then we're asked to find the internal temperature of the potato at t equals 3 given this new function. So we're going to go ahead and solve that differential. The first thing we have to do then is separate the variables. So dg dt is going to equal g minus 27 to the 2/3, and sorry, it's negative. So we're going to get dg over g minus 27 to the 2/3 equals -1 dt, and we're going to do our integrals. Now, in order to take the antiderivative of this, it's probably easier to write it as a negative exponent. So we're going to write it as a -2/3. And then on the right side, we can just take the antiderivative, and it's -t plus c. And then here, if we're going to add 1 to the exponent, that's going to be a 1/3. But then we have to think about the chain rule that would come from it. So if I had a 1/3 and needed to drop it, I would need a 3 in front in order to cancel it. And there's no chain rule from the g minus 27, which is kind of nice. So we don't have to worry about that. -t plus c. And now we're going to use our initial condition to solve for c. So we originally had 0, 91. So 3 times 91 minus 27 to the 1/3 is equal to 0 plus c. So we get 364 to the 1/3 is equal to c. 64 to the 1/3 really means the cubed root of 64, which is 4. And so we get that 12 is equal to c. And so now we're going to use this to go ahead and actually solve for g now. So I'm going to go back to where my antiderivatives were. So 3 g minus 27 to the 1/3 is equal to -t plus 12. And now I'm going to solve for g. So I'm going to start by dividing by 3. So this is -t plus 12 divided by 3. Now we could simplify that if we want to, but there's not really going to be any need to. In order to get rid of this 1/3 power, we're going to need to raise it to the third, which means raise the other side to the third power also. And so now we get g minus 27 is equal to -t plus 12 over 3 raised to the third. And now we can just add that 27 over. So we get g of t is equal to 27 plus -t plus 12 all over 3 raised to the third power. So there's our expression for g of t. Now remember, this was not the end of the problem though. They asked us to find the internal temperature at time t equals 3. So that means we're going to find g of 3 by just plugging it in. So 27 plus -3 plus 12 over 3 to the third. And so we get 27 plus -3 plus 12 is 9 over 3 is 3 raised to the third. And so we get that g of 3 is equal to 27 plus 27, which is going to give us 54 degrees Celsius. Now, I just want to point out to you really quickly, we found the actual temperature now based on this model to be 54 degrees. In part A, we made an estimate that it was 43 degrees. In part B, we said that that estimate is an underestimate. So we can see that that's actually true then. So that's a good way to kind of check yourself on this and kind of just make sure you've got the right thing going on. This was worth 5 points, which is pretty typical of a solving a differential equation. So it was 1 point for remembering to separate your variables, just like usual. It was 2 points for your antiderivatives. 1 point for your finding your plus c and remembering to put your plus c. And then it was 1 point for getting your expression of g of t and for solving for g of 3. So if you forget to do this as this actual evaluating right here, then you would lose that point. So make sure you always go back to the directions and read kind of what's going on. All right, thanks for watching.